Alright, AP, this is sample exercise 3.90. We're talking about limiting reactants. Nitrogen gas can be prepared by passing gaseous ammonia over solid copper 2 oxide at high temperatures. The other products of the reaction are solid copper and water vapor. If a sample containing 18.1 grams of ammonia is reacted with 90.4 grams of copper 2 oxide, which is the limiting reactant? And how many grams of N2 nitrogen gas will be formed? So two different questions there. Go ahead and press pause now because here come the solutions. A little bit of a longer solution, so you have to bear with me here. So from the description in the problem, we can obtain the following balanced equation. 2 ammonias plus 3 copper 2 oxides react to form 1 nitrogen gas, 3 coppers, and 3 waters. Next, we compute the moles of ammonia, which has a molar mass of 17.03 grams per mole, and of copper 2 oxide, which has a molar mass of 79.55 grams per mole. And so taking the mass of each of the reactants given, we were given 18.1 grams of ammonia, and we were given 90.4 grams of copper 2 oxide. We take the molar mass of each substance, use it as a conversion factor, and we'll generate a mole value for each of the substances. 1.06 moles of ammonia, 1.14 moles of copper 2 oxide. Now, to determine the limiting reactant, we use the mole ratio for copper 2 oxide and ammonia. If we pick 1.06 moles of ammonia, and we use the mole ratio to convert into moles of copper 2 oxide, we generate the value 1.59 moles of copper 2 oxide. Therefore, what we can claim right now is that 1.59 moles of copper 2 oxide is required to react with 1.06 moles of ammonia. Since only 1.14 moles of copper 2 oxide is actually present, remember this is how much we have here, okay, given by the question, the 90.4 grams. Okay, this was given by the question. Since we only have 1.14 moles of copper 2 oxide, and it's less than this 1.59. The amount of copper 2 oxide is therefore limiting. The copper 2 oxide will run out before the ammonia does. We can verify this conclusion by comparing the mole ratio of copper 2 oxide and ammonia required by the balanced equation. When we look at moles of copper 2 oxide divided by moles of ammonia, we're going to get a ratio of 3 to 2, or 1.5 as a decimal. The mole ratio that's actually present is actually 1.14 divided by 106. That's a mole ratio of 1.08. It means we don't actually have what is required. We actually have less than that, and so we're going to run out. Since the actual ratio, let's see, scoot up, a little bit more. So since the actual ratio is too small, meaning it's smaller than the 1.5, copper 2 oxide is the limiting reactant. Because copper 2 oxide is the limiting reactant, we must use the amount of copper 2 oxide, the limiting reactant, to calculate the amount of N2 formed. From the balanced equation, the mole ratio between copper 2 oxide and nitrogen is 1 to 3. And so we take the amount that we know is going to react, which is the 1.14 moles of copper 2 oxide, because it's going to limit us, so all of that is going to react. All of the limiting reactant always reacts. We use our 1 to 3 ratio, and we generate an amount of N2 produced, and so we get 0.380 moles of N2. Then simply using the molar mass of N2, which is 28.0 grams per mole, you can calculate the mass of N2 produced, which ends up being 10.6 grams of nitrogen gas.